Hi, I'm Andrew Connell, and I'm an MVP for Office Servers and Services and Office Development. In this module, we're going to talk about Microsoft Graph capabilities, and specifically in this section, we're going to talk about working with Graph Delta queries. We're going to look at the optional query parameters, paging with NextLink, changing tokens with a Delta link, and supported resources for Delta queries. So there are a bunch of additional properties or optional properties that we can pass on the query string to configure how the query works that we submit to the Microsoft Graph. And these are all OData-based properties. So you can see here we have a count, which is going to give us a total count matching specified resources. We can include expand, which will open up other related resources. Filter allows us to filter the results or the rows that come back. Order by is exactly what it sounds like. You can order by a field and optionally pass in the DESC on additional property under that, which will sort it in descending order. There's search, there's select. Select is going to give us things like give us the like a select statement on a T-SQL statement. Just give us the fields that we're interested in. Skip allows you to skip a specific number of results. That's really good for paging. A skip token will retrieve the next page of results from the result set that span multiple pages. Some APIs use skip instead. And then top is only going to give us the first results that we want to get back. The filter property it's going to vary as support across the different graph APIs, but the following things are generally supported. Things like equals and not equals, and the ones that you see there listed on the screen or on the slide. Now, the other thing we can use is something called the NextLink property. So some queries against the Microsoft Graph are going to return multiple pages of data, either due to server-side paging or due to the use of the top query parameter to specifically limit the page size within a request. When a result set spans multiple pages, the Microsoft Graph will return the odata.nextlink property in the response that contains a URL to the next page of results. Paging behavior varies across different graph APIs. You're going to consider the following things when you're working with paging data. Different APIs may have different default and maximum page size values. Different APIs may behave differently if you specify a page size using the top query parameter that exceeds the maximum page size for that API. So depending on the API, the requested page size may be ignored. It might just default to the maximum page size, or it might return an error. So make sure you check with the different API or the resource on how it performs. Not all resources or relationships are going to support paging. For example, queries against directory roles don't support paging at all. This includes reading role objects themselves as well as role members. Some APIs support backward paging by appending the previous page query parameter, such as previous page -- true, to the URL value of the NextLink property. After you append this parameter to a request, the NextLink URL and the subsequent responses will include it. You can continue to page backward until the response with an empty result set's return. Paging even further than that, that's going to give you an error. So alternatively, you can assume paging forward from the current response by removing the previous page parameter when you send a request for the next page of results. Now, another option here is using something called the Delta link and change tokens. Delta queries are allowing you to query for newly created, updated, or deleted entities without a full read on the target resource. This is going to be useful for synchronizing changes to a local data store. It's going to require permission to read the requested resource. So you're going to get a NextLink property. And what that's going to do is that's going to allow you to indicate that there's more data available. So you'll go NextLink, NextLink, NextLink to keep going all the way down. When you see the presence of a Delta link, that's going to indicate no more data was returned, and it's going to contain a Delta token. You're going to want to save that for future queries, because if you include that in a future query, it'll only give you back the things that have changed since the last time you made the request. So how does this work? Well, first, a Delta query is going to be made to a collection of resources and specify all the properties that you want to select. The data is going to be returned along with a next link response header, indicating that there's some more data available to us. The next link is going to be a query which encodes the select part of the statement inside of it, and it's going to return the data and a delta link response header, indicating that no further data is going to be available. And after some time, the application can then query for changes again by querying using the same delta link. A single record is going to be returned indicating a change along with a new delta record. So what resources support delta queries? Well, we have events in a calendar view, groups, mail folders, messages in a folder like your inbox, personal contact folders, personal contacts within a folder, users, drive items such as things in OneDrive, and events in a calendar view. Now, the delta queries for drives are going to be updated in the future to be a little bit more consistent with resource types. Right now, they're not terribly consistent with all the other resource types, but in the future, they will be updated to be more consistent. So in this first demo, we're going to show you how to query for changes to a resource. Now, instead of going and creating a Azure AD application, I'm going to show you one that I've already created previously. So you can see it's got a name of user changes demo. It's got an ID. I also generated a secret using the standard process of just clicking and creating a new. Now I added a web platform as well, and I chose to do a native application in this case here. When you create a native application, it creates both a native and a web application. So here I've got a web redirect uDirect URL pointing to the localhost, and our native application here has our client ID, client URI. Now if I scroll down a little bit and I look at the permissions, you can see that I have a permission here that I went ahead and added for user read write all. So you can see here at the bottom that I've got it selected. Now you can see here you can't consent to this as a user. The only way that I can do this is a admin consent. So then because of the admin consent we're going to need, I'm going to go ahead and grab the application ID. So what I'm going to do here is I'm going to take an existing admin consent URL that I've using as a template here that's provided in the lab associated with this demo. And I'm going to simply replace the client ID with the ID of the application ID that I just copied from the application I had created previously. So I'm going to copy that entire URL and I'm going to paste it into a browser. It's going to prompt me first to authenticate or to sign in as a global tenant administrator. Now here I'm being prompted to grant permissions to this, and you see here when I'm doing this, I'm getting an additional paragraph to say that it's going to be granting access to all users to use this application, or for this application to work with all users' identities, and that's because we're doing an admin consent. So that's going to redirect back to HP localhost, but again, we don't have a web application listening on localhost, so it's just going to give us an error, but it does say admin consent equals true, which shows that our administrative consent is already done. So we do have the consent part already taken care of. So since we have admin consent, let's go look at our application now. And specifically, let's look at the app config. So the client ID, the secret, and the tenant, all of those came back from creating our application that you saw previously. And the tenant ID is using just the ID of our Office 365 tenant. Now, if I look at the program.cs file here, when I enter into the main method here, I'm going to then call the run async method. And what this is going to do is grab the client ID and the tenant ID in the authority format. And then I'm going to create a new confidential client application, passing in the client ID, the authority, the reply URI, and the client secret, and then create a token cache where it can store my cache later. Now, if I look at the graph service client a little bit farther down, what that's going to do is that's going to make a call to the graph URL, and then it's going to delegate the authentication process. So in here, it's decoupling MSAL away from graph and giving me access just to the request message. So then it's up to me to use whatever library or API I want to apply the request message header for authorization to get access to graph. And in this case here, I'm using the acquire token from async method to request a token from MSAL, and then use the authentication header to attach the bearer token to attach to the HTTP request. now that I've told Graph how to do everything, the next thing I'm going to do is I'm actually going to go try and get all my users. So I'm going to say graph client.users, and I'm going to issue a Delta request or Delta query, and then issue a request, and then tell it the fields that I want in the select piece, and then say get async. And what that's going to do is that's going to give us all of the users because it's the very first time that we're querying for all the users. And then it's going to display the users and give us a Delta link. I then have a method that's going to show us a list of all the users, and it's also going to show us the Delta link itself. So let me go show you this implementation of this function here of the display change users and get the Delta link. It's going to first enumerate through all of the users, and it's going to write out all the users in that current page, and then go to show them the display, the user and their name and their principal name. And then I'm going to check to see, do I have a next page request? And what that's going to do is that's going to give us the next link and a skip token. Now, by telling it to get the user page, next page request, get async, that's then going to go to the next page of users and write those out. And that's going to keep going through each page and page of users to show a list of all those different users and writing out their principal name and their display name. And then finally, I'm going to get the Delta link. And the Delta link is going to basically say that give me a placeholder that says after we've processed this set of changes, then give me a Delta link so that when I make another request using that same link, I want to start from this point forward and only show me those things going forward. So kind of like change tokens from this point, and all of it's changed since this time that I just issued this request. So once I've gone through that whole process of getting that Delta link, now in order for us to force a change here, I'm going to add a user. So I'm going to use the Graph API to create a brand new user called users Delta query demo user. Give him a name, a surname, a nickname, a principal name. I'm going to specify all that stuff, set the password profile, and then I'll set a breakpoint here after we've created the user to go get all the users again. And when I do that, I'm going to call this function to initialize a next page request. And because I already have a Delta link, I'm essentially going to say, go give me the next page of requests using the Delta link. And that says, I don't want everything from when I started initially. I want to start from the endpoint of the query I just made. So it's not going to give me everybody. It's just going to give me the ones that have changed. So in this case here, in my demo tenant, because I'm the only one using it, I should only get one user back. And when I issue that next page request, I just walk through the same process of showing me all the changes, but it's only going to show me that one user, as I just mentioned a second ago. And then I'm going to want to get a new Delta link, or make sure while the Delta link equals a new Delta link. If they're the same, then I haven't gotten any new changes yet. And so as long as the Delta link hasn't changed, then I know that I have more and more pages of in my second request, I'm getting more pages of users that I want to go back and show. And once those two things are different, once the Delta link is different than the original Delta link, then I want to save that new one because that's the one I'm going to use going forward. I don't need to, that indicates that I'm at the end of this page of all of these users. So let's see this guy run. So I'm going to run this the first time. So it's first going to give me a list of all the users, and then it's going to give me all the users, and then I hit my breakpoint to go add a new user. So now when it goes to add a user, it's going to create the user. It's then going to go create the new user asynchronously. So now the user's been created, and now I'm going to run back through as to go get another batch of users. So you see here, let's get a list of all my users. And then I added a new user, you see there at the bottom. And if I go over to Office Admin Center to prove that I actually created a new user, so I'm going to go to all users here. And if I scroll down, I should see there's our user, Delta query demo user we just created. So we can see that he's actually been initiated or been created. And now when I continue with the process, it's then going to go get create a new link, a new request here. And if I look at the Delta link that's created here, so then it's going to use that Delta link to then go get a list of all of the new users or all the things that have changed since the last time I made this request. So here I'm getting a new Delta link. It's then going to run through and show me a list of all those users. And now you can see that I'm getting my only one user back. I'm not getting all my users. I'm only getting the one user from this last change that I made. And then I'm going to go have some code here that's then going to delete that same user we just created and delete him asynchronously. And so what that's shown is how to use the Delta link to get the first big batch of users that I want to get back, or first big batch of data, and then using the Delta link to say, show me everything that's happened or changed since that first request that I made. Now in this section, let's talk about webhooks and understand how webhooks work, how to configure them, and how to retrieve changes from webhooks. Webhooks are HTTP requests that are made up from the Microsoft Graph to a web endpoint that I configure when I create a subscription. The endpoint is going to use HTTPS, and the endpoint must be publicly accessible. I can't register an endpoint that is not routable behind a firewall, such as HTTPS/localhost. During testing, I could use a tool for testing this, such as a tool called ngrok, which I'd go take a look at. It's ngrok. It's great for testing, and it basically creates a publicly routable URL, but it maps to something on localhost. The way that this is going to work is I'm first going to issue a subscription request to the Microsoft Graph for a specific resource. The Microsoft Graph will then first immediately make a request to the endpoint that I told it to create a subscription to, and it's going to pass over a little token. That token, I then have to respond with that token right away to show it that I have a valid service that can listen for webhook notifications. Once I've done that, then the Graph will notify me whenever something changes, whatever I requested. Now, these subscriptions are only valid for a certain amount of time, so I am going to have to renew these subscriptions over time. Let's look at this in action. So my application is first going to send an HTTP post to the Microsoft Graph endpoint at graph.microsoft.com/v1/subscriptions. And then in step 2, Microsoft is going to send an HTTP post to the URL with a query string value of validation token equals something. And my application's just got a few seconds to respond with an HTTP 200 OK and put the value of that token in a plain text response body. If my API responds within 10 seconds, then my response to the original token request is sent back to my original application. So you see that with a 201 created. Finally, my API will receive notifications for the given resource for the duration of the subscription. Now, my application is going to need to update the subscription request prior to the timeout of when the subscription is going to expire, or I'm going to have to create a new one. Now, when I receive a notification, I can then make a request back to the Microsoft Graph to request additional information about the changed resource. The initial subscription request includes a client state, which should be matched against the client state that I sent from Microsoft. My API has got about 10 seconds to reply to a notification that comes back with an HTTP 200 before Microsoft is going to try and respond or resend the request. Now, the Graph REST API uses a webhook mechanism to deliver notifications to clients. A client is a web service that configures its own URL to receive the notifications. Client apps use notifications to update their state upon those different changes. So using the Microsoft Graph REST API, an app can subscribe to changes on the following resources, things like messages, events, contacts, group conversations, content shared on OneDrive, including drives associated with SharePoint sites, and a user's personal OneDrive folders. Now, it's important to note that all resources subscriptions will expire after a certain amount of time. Most of them are the same, 4,230 minutes, which comes out to about 70 hours, so just a couple days. The drive root items, or items in the root of OneDrive, those are going to be much longer, 86,000 minutes. So one of the nice things is that when you get the notifications, it will tell you when the expiration of this subscription happens. So if it's a very chatty-based API that you're using, so if like you're subscribing to new mail coming in and you are getting mail like every single day, then you can keep watching to see when the subscription is going to expire and then proactively renew your subscription to make sure that it doesn't expire. So in the previous demo, I showed you how to use the Delta link and to poll for changes using the Delta link. And this process in this demo here, I'm going to show you how to work with a webhook and have Graph notify me when there's changes that happen, so that I can respond to them. Now, this is only supported on specific resources. It's only going to be supported on specific resources, but it allows me to avoid polling. So I already have an application created here that I have my application ID, I have an application password. Here I have a web platform that's set up called the Graph Webhook Demo AzureWebsites.net. And then on the permissions, I don't have any additional permissions that have been set up here. Now, if I go over to the Azure dashboard, I'll show you an application that I've already deployed called the Graph Webhook Demo. And if I go take a look at this web application, that's giving me the URL of our web app. So here's graphwebhookdemo.azurewebsites.net. It says HTTP, but it also will respond to HTTPS. So let's go take a look at the web application here. So here what I've done is I have the client ID and secret in for a web application here. And this, if you want to do this yourself, there's a lab associated with building this demo that goes along with this demo. So I just want to show you how this runs and kind of walk you through the application that you would end up building. So here I'm pointing to our Graph Webhook Demo AzureWebsites.net website. And then I have to specify the redirect URI of where do I want the user to be redirected to, but I've also set the client ID and secret here for this application. If I go take a look at this startup auth.cs file, in the OpenID Connect handler here, I'm going to configure the scope to be the same scope as what is in the project that I started from when I cloned the repo from a previous demo, except I added in the mail.send scope. So in the notifications piece here, this is where I get a response back from Azure AD. And what I'm going to do when I get the authorization code back, I'm going to give it a list of scopes again, and I'm going to pass in the mail.send scope and tell it to go get a token using the authorization code. And I'm going to pass in the code and a list of scopes. Now, what that's going to do is going to go to Azure AD to get a refresh token, the ID token, and the access token that's valid for mail.read and mail.send. And it's going to put that into the token cache. By having that in the cache, then when I go over to the subscription controller, once I've already logged in, the subscription controller is going to be used for when a user wants to create a subscription to a webhook. So I'm going to tell it to go to a specific endpoint here. So graphmicrosoft.com/vo1 subscriptions. You see that up on line 33. I'm then going to create an HTTP client and pass in a new request here. So I'm creating a new request message and then create a new subscription object. And that subscription object right there on line 41 is going to say, go look at the current user's inbox, his messages collection, and I want to be notified when the change type equals creative. So when a new item is added to my my inbox, so I receive a new email, and then I'm going to tell it for how long where I want to be notified. So the notified URL is where it's going to be sent to, and then the expiration date is how long this is going to be valid. And then once that's done, I'm then going to take the response back that I get and put that in the request to submit it back over. Now, I'm also going to have to do this. I'm still going to have to authenticate. So here I'm going to go into this MSAL session cache and fetch the user's token for this graph application. And then I'm going to create a client application or a confidential client using the ID, the redirect URI, and the token that we used. And it's going to acquire token asynchronously or silently asynchronously, which will get the actual token we get back. And then I can add the access token back to the request value to then send the post message to the subscription endpoint on the graph endpoint. And then the rest of it is just storing the subscription information for later use if I want to store it inside of a database or something like that to cancel it later if I wanted to. So this is just review is just telling Graph that I want to be notified when a change happens. So when Graph gets that request, it's going to send an HTTP post to our listen endpoint. And our listen endpoint has to respond right away with the validation token that it's going to send me. And this is just so that I can let it know that, hey, I want to be notified when you get this request. So what this is doing is basically Graph is saying, hey, you wanted a subscription? Make sure that, tell me that the place where you want to subscribe or that you want to be notified, make sure that that's supposed to be there. So I'm just going to take that validation token that Graph sends back to me, and I'm going to respond back to Graph with that validation token as just plain value right inside the body and plain text of the response. So that Graph now says, okay, I know that where you want to be notified is there and that it's valid. Now, as far as development goes with this, I would not put a breakpoint anywhere like in lines 56 through 59 because this has to be a fast response. So use like trace or debug statements to be able to figure that out. So then when I get an actual notification message via our webhook, I'm going to deserialize. I'm going to read all the data in as a stream and then deserialize it into a notification object. And here I'm then going to add it into an array inside of our application statement to just say, hey, look, I've been notified whenever we get a notification that there was a new email. That's all I'm really trying to track here. So let's go ahead and let's try this. So I'm going to go right click and publish this. I'm going to publish this to our Azure web app. I'm going to do that by just creating a new profile, select our Graph Webhook demo web app inside of Azure, and then I'm going to go modify the settings for this. When I change the settings for this, I'm going to switch it from release to debug mode so that I can do remote debugging from Visual Studio locally to the Azure web app. And then I'm just going to go ahead and click publish. Now I already have a breakpoint or two that's been set here inside of my application. So now we see our application is now up and running, and now we're in good shape. So now let's go back over to Visual Studio and let's attach a debugger to our application so that we can actually see our. Let's go ahead and click attach debugger to attach it to our Azure web application. So now we've got Visual Studio attached to the debugger. So let's first go ahead and sign in. So I will log in using my administrator account. Now, the first thing I want to do is I'm going to want to subscribe to the webhook. Now, you can see the previous things we could do before, like reading an email and sending an email, but I want to see I want to show you how to do the subscribe or see how the subscribe and the notifications work. So if I go to notifications, you see that I have no notifications that are listed here. I've not been notified of any new emails that are showing up. So I'm going to click on the subscribe button. And what that's going to do is that's going to go subscribe to the Microsoft Graph to be notified whenever there are whenever there's a new email that actually comes in. Here, this is showing me that all of this was successful. So my subscription has an ID. It's got a client state was passed in. And then I'll click on watch notifications to see when anything comes in. So no, we haven't received any email yet. So I have no notification showing up. But if I go over to send email and I send an email to the current user, so I'm just going to take the email address for my current user. So I'm just sending it to myself. The subject would just be notifications and a message can be anything you want. So I'll just say, this will trigger a notification. And I'll go ahead and click send. So it'll take a second for my email to actually get sent out and back to myself. As you can see that Visual Studio will then trap that notification that just came in. So our breakpoint got hit. So if I hit F5, we can then go click on notifications and we should be able to see a new notification for something that was just created. So there we go under users. And there's the GUID for my mailbox and then messages, and there's the actual message. And if I go to read email, I should be able to see the email that we just kicked off. Will trigger a notification. So there's the proof that our webhook is actually working. So here in this demo, what you saw is how to create a subscription to the Graph endpoint. And we want to be notified when a new email is received. Once we got our email, we then took our email and once our email we had an email that showed up inside the mailbox. notification was sent to our endpoint to let us know a new mail showed up. And then we could then record that, and we took a look at that notification. You could use this for whatever you see fit you want to act on new things that are showing up inside of an inbox, or for any other graph resource that supports webhooks. Now in this section, let's talk about adding custom data to resources using the Microsoft Graph. And there's two different things we'll talk about here: open extensions and schema extensions. We can extend the Microsoft Graph by adding custom data to resources using extensions. I can keep your app, my app lightweight, and store app-specific user profile data in the Microsoft Graph. I can keep my existing user profile store and add an app specific identifier to Microsoft Graph. I can also add metadata to messages to provide new conversation capabilities, or even enhance calendar events with contextual data. There's two ways we can do this, either using open extensions or schema extensions. Open extensions are a really good way for us to get started with this. They're going to open up different types that allow a very flexible way to add untyped data for app data directly to a resource instance. They're accessible through the extensions navigation property on the resource instance itself. The extension name is the only predefined writable property. It must be unique within the tenant. You can use a reverse DNS naming system, for example, like com.contoso.contactinfo, but you shouldn't use something like with Microsoft in it, so like com.microsoft or com.onmicrosoft. So this slide just shows an example of what we would get back. So in this case here, I'm making a request for a user, and I'm saying expand the extensions. And here you can see I have one extension that's being expanded. Here the ID of this extension, or the name of it, is com.contoso.roaming settings. And in this case here, it's got three properties: a theme, a color, and a language. Now, another type of extension that we can do is a schema extension. Now, these are a little more versatile. We can define a schema extension ahead of time as using a definition, and then extend the resource instances with strongly typed custom data. It's discoverable by other apps using a status property. Now, schema extensions are complex types, enabling the use of different HTTP verbs like post, get, and patch to update or to set complex data, either to null, which would be effectively deleting it, or by updating it using an existing resource instance. One of the other things that I can do with a schema extension is I can actually query on the different values. I can't do that with the open extensions. So here's an example of a schema extension. Here I'm making an HTTP GET to a specific endpoint, and notice that I'm actually doing a filter on the course ID, or where it says the graph learn _ courses. That's the name of my schema extension, and you can see that I'm querying on a specific ID, a course ID equal to 123, and then I'm selecting all that data back. The response I get back, you can see that the custom data from the graph learn _ courses is part of the full object that I have here for this resource that we're looking at, which in fact is an Office 365 group. So what things support extensions? Well, you can see here that virtually everything: users, personal contact, organization, messages, group calendar, group conversation posts and calendar events, groups, devices, and calendar events. All of these are supported at the general release. An administrative unit is only available at preview at this present time for both open and schema extensions. So what's the life cycle of a schema extension? Well, you have a couple of different states. We have an in development state, and this is the initial state. Only the owner app can extend the resource instances with this schema definition, and only in the same directory where the owner app is registered. Only the owner app can update the extension definition with additional changes or delete it. And the owner app can also move from in development to available. When is it available, it's for use in all apps by any tenant. And any app can add custom data to instances of those resource types. Now, only the owner app can update the extension definition with additional changes. No app can delete an extension definition while it is in the available state. And the owner app can move from available to deprecated. Once an app has been deprecated or in the deprecated state, schema extensions definitions can no longer be read or modified. No app can view, update, or add additional properties or delete the extension. Apps can still read, update, or delete existing extension property values. Now, the owner app can move from the deprecated state back to available if they so choose. So let's talk a little bit about the permissions and the data limits. For the permissions, the same permissions that are required to read or write from a resource are also required to read or write to any extension on that resource. To create and manage a schema extension, an app must be granted the directory access as user all scope. So what about the limits? How much data can I put in here? Well, for an open extension, each extension can have up to 2K of data, including the definition itself. An app can add up to 2 extensions per resource instance. Schema extensions limits, though, differ a little bit. The application can have no more than 5 extensions per application. And a directory resource, things like devices, groups, and users, they're limited to the total number of property extension values that can be set on a resource instance to 100. So this application is going to show how to add custom data to resources in the Microsoft Graph. So I already have an Azure AD application that's been created. I've got an ID that's already been specified. I don't need a secret. And I've created a platform as a native application, and I've passed in additional permissions for directory access as user all and group read write all. And these are both delegate permissions. So I'm logged in as a user. Let's take a look at the code for our application. So again, the lab associated with this demo is going to walk you through creating this. But here, if I look under app config, I've got the ID specified for my application, or client ID. So here, I've split out my application into 2 different sections here. We have an open extension demo class and a schema extensions demo. So those are 2 very different things. So we'll look at each one separately. So an open extension is kind of like user profile kind of information. So I can just throw in anything I want in there, and it's just very unstructured. So in the open extensions, so here I'm going to create a new public client application using the client that we had, and I'm going to specify the scopes of user.readWrite. That's all I'm going to need is to rewrite the current user's profile information, because that's all this extension is going to do is just add something to their current profile. I'm then going to go get a token asynchronously, but notice I'm going to do it interactively, not with the silent option. So I'm going to get the user to go log in, and then once they've done that, I'll then grab the access token and add that to a graph URL request that you see on lines 25 and 26 by passing in the authorization header. I'm then going to use that token or that client in a couple different ways. So the first way, I'm going to add roaming profile information asynchronously. So I'm going to create a new HTTP post request to me/extensions, and I'm going to tell it the extension name is going to be com.contoso.roaming settings. The theme is dark, the color is purple, and the language is Japanese. I'm then going to, they say like this would be good for like say maybe a game developer. So I'm then going to send this request, post it asynchronously over to Graph. And then I have a method here that's just going to write code and reason to console. So let's see what this does. All this is doing is just changing the background color from black to green, sets the status code. If it's a error code, then it will change it to red and white text, red background and white text. And then it also gives me a reason. And then it switches it back to the defaults. Nothing special with this, just to show that my changes were actually saved. Now the next one is going to retrieve the settings. So retrieve roaming profile information async. This one's going to do a select to get the ID, display name, and mail, and then it's going to expand out the extensions. And then I'm going to pretty print that out to the console. Now to update it, this is going to be doing an HTTP patch to the same extension, and I'm just going to change the colors and the language to English. And that's just going to display if it worked or not. And then finally, I'm going to delete the roaming profile information that's specified, which is just to issue an HTTP delete to that extension that I just specified and submit it. So let's see this guy run in action. So I hit F5. Here we get to our open extension demo is first. It'll first have me log in. So I'll go ahead and log in. And here we're going to first add the roaming profile information. So I'll hit F5. And then if I go look at the console and see what just happened, you can see that it's actually submitted and it's written it all out to the screen, no errors. So you can see there's a specific user and extensions, and it's specified some of the stuff that's been set in this extension here, as well as the ID. Now I'm going to retrieve the information. See, looking at the output of the request that we made, we're just getting back the user's information, the user ID, their display name, their mail, and then I expanded their extensions, which is giving us the open type extension with the different types and the name of the extension we specified. Now I'm going to update it. So remember, before the language was set to Japanese, so let's see the language switch over to English. And when we do the update, we don't get any kind of changes coming back. So there are no changes, but green shows that everything was fine. The request was good, response was good, and we're in good shape. And then finally, I can delete those. And deleting it will delete the extension that we just set up. Now, the other option is to do a schema extension. And a schema extension is a little bit different because what it will allow us to do is to extend the schema and allows us to add additional features or additional properties on the user's settings, or the user's graph settings. And so that way we'll be able to actually query known properties that we're defining. So here, let's take a look at code for this. I'm going to create a new public client application, and his scopes is going to be group read write all and directory access as user all, because we're adding a lot more stuff. Now I'm logged in as the global tenant administrator, so that's what's giving me access to do this stuff. So here is prompting me to say, do you want to grant consent to do these things? So in this case here, I say, yes, I want to give it access to the directory as me and read write access to all the groups. And then I'm going to go get a token. And then I'm going to create an HTTP client. And here I'm going to the graph, creating an authorization. And then I'm going to view all of the extensions that are available to me. So first, let's go look at all of them. So that's what this first function is doing by passing in the client. Let's see what this does. Now, the way we do this is I'm going to do an HTTP GET and go pass in the schema extensions. This is using the same base URI that I was using off graph. I'm going to send it and get the response. I'm going to write the code and the reason in the console and parse the result and write out the response. So let's just see what happened. If I scroll up, these are all the different extensions that we have available to us on a whole bunch of extensions that are available to us that have been defined. So I have one for governor, leave type, just a bunch of different properties I can use. So then I'm going to register a new one. So here in this registration of schema extension, we can see that it was created and it tells us some information about it. So we have the description called Graph Learn Training Courses Extensions. So we have a status is in development. The owner is this GUID, which is, sorry, we have an owner with GUID, and then we have a property for course ID, course name, and course type. So these are now properties that are going to show up on this users, on all the users in our directory to see those properties. Now then I'm going to have to sleep for a little bit here, because the reason why I have to sleep is I have to sleep to let this actually get created. This is not a synchronous thing. It's going to take a few seconds for it to actually happen. So once the sleep actually goes past that, once we've actually made sure it's been created, I'm then going to create a new Office 365 group with that data. So say create group with an extended data async method. If I take a look at this, this is going to be creating a new group. And you see I'm specifying the display name, the description, the group types. And then if I scroll down a little bit farther, see where it talks about the schema ID on line 131. Notice that I'm passing in 3 of my new properties here: course ID, course name, and course type. These are the extensions. This is the extension of the schema for in the directory that I want to show up for this group here that I just defined as a new schema extension. So now that I have that value, I then go hit F5 to then go create our new Office 365 group with these these additional properties. And you can see that everything has been created. We have a description, a display name, mail properties, all the information about our Office 365 group that's been defined. Now, our extended properties have also been defined, but they aren't coming back in the query that we're getting back. Now it's been created. Now let's go update that custom data that we just defined. So I'm going to have a function here called update custom data in group async. So I'm going to pass in, make an HTTP patch method, pass in the groups collection and the group ID, and then I'm going to change some of the values here. So instead of the course ID 2017 and the name and the course name, I'm going to change it to some new values, and then I'm going to submit this over to the graph endpoint and write the reason and code out to the console. And because it's a patch, I get no content coming back, but you see it's green, so everything was successful. So let's go keep running our app to see the results come back. Again, I'm going to sleep for just a little bit here to wait and see the request come back. So then I'm going to go get the group and get the data from it asynchronously. So here I'm going to do an HTTP GET request, passing in a filter and a course ID, and say I'm only looking for the course ID equals 123. You could not do this previously. I couldn't have done this filter with the open extensions because you can only do this with the with a schema extension, not an open extension. And then here I'm actually pulling the values back, like display name, ID, and description. So I'll go ahead and hit F5 and watch the response that comes back. So here we go. Here's the response that came back. And so if I take a look at the results here, you can see that the display name is set to new managers 2017, but you see a couple new values. Course ID is now 123, and the course name is new managers. So we can see that our change did take place. And then the last step is I can go clean up the work that I just did. So I can delete the group and the extension asynchronously by passing in the client ID, the schema ID, and the group ID by passing those into this function. And here on a delete, when that completes, you can see we get no content back. So what that showed was two ways you can extend a graph schema. I can do an open schema, an open extension, and also a schema extension. And a schema extension allows me to do searches and filtering based on the values that are there because it's known properties and not just kind of a big property pack. Now in this section, let's talk about working with the Insights endpoint on the Microsoft Graph. So let's understand what the Insights resource type is, and then what trending is, what used is, what shared is, and then how we can retrieve Insights collections. Now, first, these are all under the beta endpoint, at least at the time of the recording. So keep in mind that they're subject to change. Using of these apps in production is not supported, but it will work. It just may not, you may have changes that happen that you're not notified of ahead of time. Now, these relationships are calculated using advanced analytics and machine learning in Office 365. The trending endpoint is going to show you documents from OneDrive and SharePoint sites that are trending around a particular user. The used endpoint are documents that are viewed and modified by the user, such as documents the user used in OneDrive for Business or in SharePoint, or opened as an email attachment. And then shared are documents that are shared with a user as an email attachment or OneDrive for Business links that are sent via email. So what are the permissions for the Insights endpoints? Well, for the delegated permissions under like work and school accounts or Azure AD accounts, you can do things like sites.read.all and sites.read-write and all. For delegated permissions for a Microsoft account or a personal account, they're currently not supported. And for application-based permissions, sites.read.all and sites.read-write.all are the permissions that are currently supported. So what kind of data do I get back? Well, every insight is returned with both a resource visualization and a resource reference complex value type. The resource reference is a reference to the item, which gives us the web URL, the ID, and the type of the item. The visualization, though, is going to give me visualization data used to display the item, like the title, the type, the media type, maybe a preview image URL, like in the case of a PowerPoint document, maybe the preview text, maybe the web URL and display name and type of the container that it's in. So let's look at the trending endpoint first. This is a rich relationship containing or connecting a user to documents that are trending around the current user or relevant to the user. Things like OneDrive files and files stored in SharePoint team sites can trend around a user. So you can see here, we have a couple things that have been returned. So we have the ID. These are the different data types that come back. The ID, we have the weight, which is a double. The resource visualization is an array of resource visualization objects, and a resource reference is an array of resource reference objects. We'll see these when we look at the demo in just a few minutes. The used endpoint is going to represent documents that are used by a specific user. The insights returns the most relevant documents that a user viewed or accessed. This includes documents in SharePoint and OneDrive for Business. And the little snippet you see here is the data type that you would find for this. Now, the shared endpoint is going to represent files that are shared with or by a specific user. Things like files attached directly in an email or a meeting invite, and OneDrive for Business and SharePoint attachments. Files stored in OneDrive for Business and SharePoint that users share as links via an email. So how do I get collections around this? Well, it's pretty straightforward. To get the items that are trending around me, I'm just going to go to the beta/me endpoint and then add on insights/trending. If I only want the resource visualizations for me, then I'd use the OData select query parameter and specify resource visualization. I can also filter specific things and say I'm only looking for attachments in email by using the sharing type equals attachment parameter. I can also show the OneNote notebooks that I've used by saying I can filter on a specific resource visualization type equal to OneNote. So let's see a demo and see these in action. So in this demo, I'm going to show how to use the Insights API. So I've already created a Azure AD application to save a little bit of time. I've got an application ID and I have an application secret password. And then I've also got under platforms, I've created a web platform where I have a redirect to 44320. This is what's going to match on my web application that we'll see in just a minute inside of our Visual Studio app. I'll show it to you now, I guess. Let's just go to a web app and I look at the properties. You can see the SSL URL is set to localhost 44320, including the trailing slash. Now, because that URL was inside the app registration portal, I also need to make sure it's inside of my web config. I've also here in the web config, I've also specified the client ID and the client secret for our application. So if I go look at the code for startup auth, this one works very similar to or it works actually exactly like all the previous ones we've already looked at. So here, this application is using the OpenID Connect to handle authentication and identity. You see here on line 53, it's got a list of all the scopes. Now what I've done is I've added in an additional scope of sites.read.all. Once the OpenID Connect code is received after authentication, I will then use that code in MSAL to create a confidential client application on line 76 and obtain a code for that scope. And that will in turn put the tokens inside of the cache so that in the future, it'll find our methods or find our tokens in the cache. For example, inside of our controllers, they'll be able to find those things inside of the cache. So if I look in the Insights controller, so the index view, if I take a look at this one first, it doesn't really do anything. It's just going to show the home page. Essentially, you'll click on some links. But if I look at insights around me that are shared, so if I scroll over, I can see that that's a beta endpoint at the time of the recording. So I'm using /beta/me/insights/shared endpoint on the Microsoft Graph. So I'm issuing that as an HTTP GET. So what I'm going to do is go to the MSAL session cache and create a client application, a confidential client application using the token cache and using the scopes for sites.read.all. And then that's going to use the acquire token silent async, which is going to try and fetch a token for that user for the scope. And if it finds it, we're in good shape. Otherwise, it'll prompt us to go authenticate. I'll then take that token and then send that request to the Insights API And if it's successful, I will then deserialize it into that collection to show a list of all those insights that came back. Trending is similar, does the exact same kind of thing. It just goes to the trending endpoint to go get the same style information, but instead of just things that are shared with me, I see things that are trending, so that are things that may be interesting to me based on my actions that I performed inside of Office 365. And then same thing, I have another one just like the trending. I also have a used endpoint as well that I can go get to see all the stuff that I've actually touched and been interactive with. So this again, just doing the exact same thing. Authenticating, getting it by using the token and the sessions. So let me jump over to the models section, because this will talk about the different objects that we're using. So if I look at insights, so insights, you can see each one of these, I have a couple different things. So I have one I have called resource visualization, and you can see the resource visualization is used in a couple different places. So if I look at who's using this resource visualization, each one of these different objects. So like there's one last used value, insights has it. Here's shared value has it as well. So there's the resource visualization as well. So each one of these has a resource visualization for the different elements. Some properties are a little bit different, but they all have that resource visualization object that's coming back. And that's important because that's how we're deserializing these and using them in the views. So let's go look at the views. Under views/insights, we have the index and then shared, trending, and used. So index is just showing me links to these other views that I want to be able to see. So view shared, view trending, and view used. So if I look at the shared, what that's going to do is that's going to show us all these different properties. And if I scroll over, you can see it just showing all these different properties. But if I scroll down a little bit farther, and then down here at the bottom, you can see at each one, it has this resource reference. All of these have a resource reference and a resource visualization. We're then going to use this partial view for each one of them. So if I look at the resource reference partial view, all of these have web URL properties and type properties. I was going to write those out. The resource visualization, each one has a media type, a preview image URL, some preview text as well. So let's go ahead and run our application. So I'm going to hit F5. So we'll first log in as a current user. So I'll sign in using our user Adele V. I'll pass in the password here to go ahead and log in as this user. Now that I've signed in, so if I go to Insights, so view trending, shared, view used. So let's go to trending. So we get a couple little errors here, i.e. in his security zones or trust zones, we're having a little bit of an error that's showing up. And it's because these images are coming from a separate domain, which isn't secure. So we're getting these like weird little errors popping up. It's just a IE zone issue. So just ignore that in the case of the graph. But I could just take this URL here and I could copy this and paste in the URL. And here it's showing us the actual resource to show the value. And if now that I've done that and I've refreshed the page, so this little issue you see here, this only really applies to IE and Edge, and it's just because of the trust zones. If I switch over to Chrome and do the exact same thing, so let's go sign in as Adele V, put in Adele V's password and sign in. And then, so now if I go to the Insights page and then go to View Trending, and notice I'm not getting all those errors that are popping up. And it's just showing that now the images just aren't going to show instead of getting all those prompts, those security prompts. And the reason why is because I don't have a valid token to see all those different values. So the reason why is because it's going to be rendering from a different domain. So if I copy this link and I paste it in, so now I already have the cookie on my machine for the image that shows up. And now if I refresh this page, now I'm getting a image actually showing up. All the other images that maybe there are all coming from the same place, and so they're all the images now are coming up with the different thumbnails. So these are all the different visualizations that are coming back for us. But the big takeaway from this demo is to be able to use the Insights API to display things that are trending, things that are shared, and things that are used by the current user from the Microsoft Graph. If you want to see how to build a demo on this, we do have how to build a sample on this. The demo code that I just showed you here does have an associated lab with it that you could run through and take a look at.